So I made a proposal about a year ago on my website talking about my dream computer. Of course, after making this post, there were numerous questions that continued to pop up, such as, why not use a Raspberry Pi? So some of my friends and I set out to design a computer that incorporated all the best bits of old school simplicity, but also try to get rid of some of the more irritating aspects, such as floppy drives.
Hello, I'm Kevin Williams from TechSelect.com. David's asked me to help him just design a quick prototype board to work with the Gameduino. We just wanted to show you real quick how it worked.
So let's see if it works. And it does. So next I set off to design a program in assembly language, which would be much faster. And at this point, I've already got a lot of screen editor functions working, and I can cursor around and type things on the screen. I'm still a long way from having a custom kernel, but it's going to be a series of baby steps to get there. This is compounded by the fact that Cloantro, the company that currently owns the right to Commodore ROM chips, refuses to even talk to me about licensing the Commodore kernel. They just won't answer me, so I guess they aren't interested. That being the case, I'm just going to have to design a new kernel from scratch. I had given it a temporary code name of Commander 16. Despite being a temporary code name, the name turned out to be quite popular, so we decided to keep it. However, we were concerned about people abbreviating it to C16, which might be easily confused with the Commodore 16, which is a very different product. So we changed the name to Commander X16 so that people would abbreviate it X16 instead. I realized that we could essentially build a VIC-20. Now this would mean going back to the 6502 processor, and of course our VIC-20 would have a lot more RAM, better video, and better audio, so it wouldn't have any of the shortcomings. Once we had a plan for the board, then we really needed a better long-term video chip solution, so I reached out to the community to some people who were FPGA experts to see if they could design a custom video chip. I ended up getting working submissions from two different people. Ross Andrews sent me this daughter board here, which we codenamed Project Vulcan. And then Frank Vandehoof sent me this little video board codenamed Project Vera. We ended up selecting the Vera chip for the long term. Kevin built this little board where the Vera daughter board can just connect in like this, and then we can plug in a VGA monitor, and you can see it here working on the C64.
This is the first fully populated board that we built to do some testing, and in this empty slot right here is actually where the Vera video module is meant to be installed.
Searching for help with the kernel, I ended up contacting Michael Steil, who's an expert with the Commodore kernel, and he became excited about the project, and so he jumped on board. And to be honest, most of the heavy lifting in this project is now being done by these three people.
Perifractic here from Retro Recipes. And it's on the subject of design as to why I was brought on board to the Commander X16 team. And the first challenge we set ourselves was looking at the logo. And it was about the time that we were looking at the logo design that we had this butterfly invasion here in California. So here is the Commander X16 butterfly logo. As you can see, we've tried to incorporate modern elements like those sharp cutting edge edges and the modern font, but with the juxtaposition of the old school color gradient. And we were able to work with David to take a version of that logo to the basic screen.
Of course, due to the way the X16's graphics layers work, I can still actually have more than 16 colors on screen, and that's because each layer can have its own palette. Nobody has yet created any sort of mod tracker player for the X16. Unfortunately, it turned out that one supplier thought they had a bunch and actually didn't. Other suppliers have sent us the chips we bought, but they turned out to be fake. We finally managed to find a supplier who has real chips, and we've already got enough stock on hand to cover the next year's worth of production. We have some amazing musicians in the X16 community, and Nico1690 took on the job of converting the music. And we also launched a GoFundMe to help raise some money to put these into production. Put them together and you have over $51,000, which is not only an amazing generosity from the community, but also showed what kind of interest there is in this project, which really energized me and the entire team and community around the X16. But since we got all this money, we thought, hey, let's build 100 instead. The motherboard assembly is the hard part. I say hard, what I really mean is just time consuming. We're talking about 6 hours of labor to put one of these boards together. This is the one we have really high hopes for that should cut our production times down dramatically. This is a solder dipping station.
Well, we certainly had a problem with the board constantly warping it, no matter what variation of temperatures and flux we tried.
Okay, so the next thing I want to show you is the case. The board will mount in here, like so. And remember, this is a standard ATX board, so you can mount it in whatever you want.
And on that note, the 65-816 or the 65C816 was originally one of the processors we had planned to use.
Yeah.
But as we moved forward in the design, very early on, the decision was made to stick with the 65C02.
If you did put an 816 in there, you'd have all the 16-bit instructions, but you wouldn't have the memory model of an 816. You'd still be limited to the memory model that we have now. One of the other questions is what happened to the $50 computer? Because that was one of the original goals, and it still is.
Recall, we were working on streamlining our production process with some better equipment last time, and despite a number of challenges, we did manage to produce some boards with the new equipment, but it became apparently obvious that we still likely wouldn't be able to produce more than 2 or 3 boards per day, consuming massive amounts of labor to do this. So we reached out to Suntronics, an electronics manufacturing company here in the Dallas area. So we're going to have them manufacture the main board, but Kevin is still going to produce the VERA boards by hand. They took me around to where the X16 boards were being worked on. They had about 50 of them being populated by hand. And here comes the board after going through the preheat stage. And here I am, taking the first board off the production line. Then it's time to put all the chips in place.
What I have here is the final prototype. This is basically the production board. It has been finished, and I am ready to show it off.